By now, 3I Atlas is at a distance of 1 billion kilometers, or 6.7 times the Earth-Sun separation, well beyond Jupiter. Our interstellar visitor appears as a fading dot.
On July 1st, 2025, a half-meter telescope in the Chilean desert flagged a faint smudge of light moving at 61 kilometers per second. Within 48 hours, the International Astronomical Union confirmed it. The third interstellar object ever detected by humanity had entered our solar system.
Big update, a huge update on our favorite interstellar object. It could be the biggest update in the solar system. Take a look at this.
They called it 3I/Atlas. Within weeks, the James Webb Space Telescope, the Hubble Space Telescope, the Very Large Telescope in Chile, and the ALMA radio array in the Atacama were all pointed at the same target. What they found was not just unprecedented, it was chemically impossible by every model of our own solar system's formation. The comet was drenched in carbon dioxide at ratios never recorded in any comet, anywhere.
What's going on with the tail? Is this now just a normal comet off-gassing sort of alien tech that's like maybe stepping on the brakes a little bit?
It was saturated with methanol at levels 70 to 120 times higher than expected, and its deuterium to hydrogen ratio was enriched by a factor of 30 to 40 times above Earth's oceans. This object formed in a star system that no longer exists, 9.6 billion years ago, and it carried the chemical fingerprint of that dead world directly into our telescopes. Let's dive in. How 3I/Atlas was found. The detection came from ATLAS, the Asteroid Terrestrial Impact Last Alert System. It is a NASA-funded network of half-meter survey telescopes designed to scan the sky for near-Earth objects on potential collision courses. The specific telescope that spotted 3I/Atlas was stationed at the Rio Hurtado Observatory in Chile. At the time of discovery, the object was 4.5 astronomical units from the Sun, just inside the orbit of Jupiter, moving at 137,000 miles per hour. But the number that immediately set off alarms was the orbital eccentricity. Bound objects in our solar system have eccentricities between 0 and just under 1. A parabolic escape trajectory equals exactly 1. 3I/Atlas registered an eccentricity of 6.14, the most extreme hyperbolic orbit ever recorded for a macroscopic body in the solar system. This thing was not from here. Astronomers then went hunting through archival data. They found pre-covery images in the Zwicky Transient Facility archives at Palomar dating back to June 28th. They found it in Atlas archives from June 14th. And then NASA's TESS satellite, which photographs vast swaths of sky to hunt for exoplanet transits, turned out to have inadvertently photographed the comet as early as May 7th. That gave scientists a 55-day observation arc before the official discovery, vastly improving the orbital calculations. The IAU formally designated it C/2025 N1 Atlas, and granted it the paramount label 3I, certifying it as the third confirmed interstellar object after 1I/Oumuamua in 2017 and 2I/Borisov in 2019. But unlike Oumuamua, which was spotted only after it had already passed the Sun and was fading fast, 3I/Atlas was caught 4 full months before perihelion. For the first time, humanity had advance warning. Where it came from and where it's going. Now here's where things get genuinely unsettling. This comet entered from the direction of the constellation Sagittarius, traveling in a retrograde orbit inclined at 175 degrees. That means it was plunging through the solar system, nearly parallel to the plane of the planets, but in the opposite direction, moving against the flow of everything in our system. Its hyperbolic excess velocity, the speed it carries at the boundary of the solar system where solar gravity becomes negligible, is 58 kilometers per second. For comparison, 1I/Oumuamua moved at 26, 2I/Borisov moved at 32. 3I/Atlas is almost twice as fast as the first interstellar object we ever detected. But the age is the part that rewrites the textbooks. Chemodynamical modeling of its galactic trajectory shows that 3I/Atlas exhibits thick disk kinematics. It oscillates far above and below the Milky Way's midplane, reaching a maximum height of nearly half a kiloparsec. Bayesian age inference algorithms place its kinematic age at approximately 9.6 billion years, with a 68% confidence interval of 7.8 to 10.3 billion years. This comet is more than twice the age of our entire solar system. It was formed, ejected from its parent star, and spent billions of years drifting through the galaxy before our sun even existed. It reached perihelion on October 29, 2025, at 1.36 astronomical units from the sun. Its closest approach to Earth came on December 19 at 1.8 astronomical units, roughly 269 million kilometers. Then on March 16, 2026, it passed within 53.6 million kilometers of Jupiter. As of right now, it is roughly 5.8 astronomical units out and accelerating back into interstellar space. We will never see it again. If an object older than the sun carrying chemistry that should not exist just passed through our solar system and you want to know what Hubble actually saw when it looked inside the coma, make sure you're subscribed, because the next section is going to change how you think about what's out there between the stars. What Hubble and Webb actually saw. Hubble executed a massive target of opportunity campaign, Program GO 17830, staging observations across multiple critical windows from July 2025 through January 2026. Using the wide-field camera 3 with the f350LP broadband filter, Hubble achieved an angular resolution of 0.04 arcseconds per pixel, peering deeper into the inner coma than any ground-based telescope could reach. And the first major finding, 3I/Atlas survived perihelion completely intact. When Hubble observed 2I/Borisov, it famously captured that comet fragmenting as it rounded the sun. 3I/Atlas did not break apart. Its irradiation mantle, the protective crust of refractory organics built up over billions of years in deep space, turned out to be remarkably thin, less than 1 centimeter deep, allowing subsurface ices to sublimate rapidly but without catastrophic structural failure. The dust mass loss rate was staggering, 12 to 120 kilograms per second, blasting off the sun-facing hemisphere in highly asymmetric jets. But here is the discovery that made astronomers lose their composure. When analysts applied a Larsen-Cecchinina rotational gradient filter to digitally subtract the uniform glow of the coma, they resolved something extraordinary. 3 distinct jets, separated by precisely 120 degrees of angular distance from one another. A perfect trisymmetric structure, and these jets were not static. Time series analysis revealed they wobble on a harmonically locked schedule with a period of 7.1 to 7.2 hours, synchronized with the rotation of the nucleus itself. Meanwhile, the James Webb Space Telescope trained its NIR SPEC and MIRI instruments on the coma and found the chemistry that broke the models. The carbon dioxide to water ratio was measured at 7.6. That is among the highest ever recorded in any comet from any star system. ALMA detected methanol to hydrogen cyanide ratios between 70 and 120, with methanol outgassing not just from the nucleus, but from large icy grains drifting through the coma, acting as miniature comets within the comet. And the VLT detected atomic nickel vapor in the coma with a complete absence of iron, an extreme elemental fractionation that mirrors what was found at 2I/Borisov. The deuterium bomb and the mass budget problem. Now here is the finding that genuinely concerns planetary scientists. In March 2026, Cordiner et al. Published JWST data confirming a massive isotopic anomaly. The deuterium to hydrogen ratio in the comet's water was measured at greater than 6.6 times 10 to the -3. That means 3I/Atlas is enriched in heavy hydrogen by a factor of 30 to 40 times above Earth's oceans and typical solar system comets. This is not a trivial number. This is a direct chemical fingerprint of the environment where this object formed. A D/H ratio that extreme means the comet condensed in an ultra-cold environment below 30 Kelvin in a chemically pristine region vastly different from our own solar nebula. Combined with the CO2 dominance and the methanol saturation, the data proves 3I/Atlas formed far beyond the frost lines of its parent star, in a system where those frost lines were located much further out, or the parent star was significantly cooler than our sun. But here is where it gets deeply uncomfortable. Astrophysicist Avi Loeb published a credible analysis highlighting what he calls the mass budget discrepancy. The isotopic data indicates 3I/Atlas came from an ancient metal-poor star system, but the total mass of heavy elements locked in all local metal-poor stars is roughly 5.4 times 10 to the negative 28 grams per cubic centimeter. The mass required to populate the galaxy with enough objects like 3I/Atlas to guarantee we would detect even one is 3 orders of magnitude higher than the available material, a factor of 1,000. Either our size estimates are drastically wrong, the metal-poor association is fundamentally incorrect, or the ejection mechanisms for interstellar objects are far more efficient than anything currently modeled. Loeb went further. He introduced the Trojan horse hypothesis, arguing that the 120-degree jets resemble a 3-axis attitude control system, that the ecliptic alignment had a 0.2% probability of occurring by chance, that the nickel without iron could indicate industrial alloys, and that the deuterium enrichment could be interpreted as nuclear fusion fuel. He initially rated 3I/Atlas a level 4 on his own interstellar object significance scale before downgrading it to level 3, as natural cometary activity became undeniable. The 11-minute conspiracy and the scientific consensus. Now see, here's where the internet went completely off the rails. Due to its intense non-gravitational acceleration from asymmetric outgassing, 3I/Atlas arrived at perihelion approximately 11 to 14 minutes earlier than purely gravitational models predicted. This is a routine orbital perturbation. Comets do this. The asymmetric gas jets mapped by Hubble provided thrust, slightly altering the trajectory. But on social media, this was repackaged as proof that the comet had executed a propulsive Oberth maneuver while hidden behind the sun. A fabricated quote attributed to physicist Michio Kaku claiming the comet was on a reconnaissance mission went viral before being debunked. Accusations that NASA and ESA were covering up telemetry or activating planetary defense protocols spread across every platform. The institutional response was unambiguous. NASA Associate Administrator Amit Kshatriya and ESA representatives stated definitively that all evidence points to it being a comet and that its behavior is entirely consistent with natural cometary physics. The 120-degree jets are viewed by mainstream dynamicists as the natural thermodynamic equilibrium morphology of a sublimating, rotating triaxial body. The 11-minute early arrival is fully accounted for by CO2-driven non-gravitational acceleration. And the panspermia implication is actually the part that should keep you up at night. The discovery of extreme abundances of methanol, hydrogen cyanide, and complex organic precursors surviving a multi-billion-year interstellar journey lends heavy empirical evidence to the hypothesis that the basic building blocks of life are being continuously distributed across the galaxy by rogue planetesimals. If organic chemistry can survive the interstellar medium locked inside cometary ice matrices for 9.6 billion years, the probability of life-seeding events occurring across the Milky Way is drastically higher than anyone previously estimated. Rubin and the Interceptor. Here is the part that makes this story a beginning, not an ending. 3I/Atlas is currently fading beyond the reach of all but the largest professional telescopes, but the infrastructure to catch the next one is already online. The Vera C. Rubin Observatory in Chile began ingesting its first solar system data products in mid-2025. Its legacy survey of space and time will scan the entire southern sky every few nights with unprecedented depth. Statistically, Rubin is projected to detect a new interstellar object every few months. We are about to go from studying singular anomalies to building population demographics of interstellar visitors. And the European Space Agency is developing Comet Interceptor, a spacecraft that will be parked at the Sun-Earth L2 Lagrange point, waiting. When Rubin or another survey detects a pristine long-period comet or a favorably aligned interstellar object, the interceptor will deploy to execute a direct flyby. Humanity's first in-situ measurements of material from another star system. 3 interstellar objects in 8 years. The first was dry and enigmatic. The second looked like one of our own comets. The third was the largest, fastest, and most chemically extreme of all 3, carrying the preserved chemistry of a dead star system older than our Sun. Each one has rewritten our understanding of what drifts between the stars, and the next one could arrive any month.